Okay, so in this problem we have a laboratory magnet which is producing a magnetic field of 1.5 Tesla. In this magnetic field we have a proton, a positively charged particle, which moves with this speed. V equals 6 times 10 to the power 6 meters per second. The question is, what is the maximum possible magnetic force that the magnetic field can exert on that proton? Well, we know that the expression for the force, magnetic force acting on the charged particle moving in the magnetic field, is QVB sine theta, where theta is the angle between velocity and magnetic field vectors. The charge of a proton is positive E. Well, because the force is given like this, where we have this sine function here, we know that the maximum value sine function can take is equal to 1. And this happens when theta is equal to pi over 2. That is perpendicular to the, when the magnetic field and velocity are perpendicular to each other. So the maximum force is when theta is equal to pi over 2, and this is QVB. Well, let's just substitute. The charge of a proton is 1.6 times 10 to minus 19 coulomb. Velocity is 6 times 10 to the power 6 meter per second times the magnetic field, which is 1.5 Tesla. And so you get 1.44 times 10 to minus 12 Newton. So that's the maximum force exerted by the magnetic field on the proton. Let's look at an example. Let's say that the magnetic field is pointing into the board, and for example the particle, the proton, is moving this way. So using the right hand rule, the direction of that force would be, if index finger is pointing along the velocity vector, middle finger is going into the board, that's the magnetic field, and then the force would be pointing up. So the force acting on this proton would be pointing upwards in this situation. The next question is, what happens if instead of a proton you now have an electron? Well, let's think about what's going to change. If you look at this expression for the force, the only characteristic of a particle is the charge. Now we know that the charge of electron is going to be exactly the same as this one, but negative, which means that the force for electron direction will be pointing in opposite direction. This would be the force of acting on the electron, so that would be the difference. The magnitude, however, will stay the same. The magnitude will be the same. Now you may ask another question. Well, what happens to the acceleration? Well, remember that the mass of the proton is bigger than the mass of electron, and therefore the acceleration on the proton is going to be smaller than that on the electron. So even though they will have the same forces in magnitude but pointing in opposite directions, their acceleration would be different because of the difference in mass.